Tell us about a recent project where you used Java extensively. What was your role and what challenges did you face?
In my last project, I was involved in developing a customer relationship management CRM system for a mid sized enterprise. The application was built using Java and Spring Boot with a RESTful API for client interactions. My role primarily involved developing and optimizing backend services, implementing RESTful endpoints, and ensuring the application adhered to solid principles. One of the significant challenges we faced was optimizing the performance of database queries. To address this, we used caching mechanisms like EHCache, which significantly reduce the response time for frequent queries.
Can you explain how Java's garbage collection works and how you've optimized it in any of your projects?
Java's garbage collection is an automatic memory management process that deallocates memory by removing objects that are no longer in use. It uses several algorithms like mark and sweep, generational garbage collection, and the G1 garbage collector. In one of my projects, we encountered performance bottlenecks due to frequent garbage collection pauses. To optimize this, we tuned the JVM parameters to better handle our application's memory usage patterns. For instance, we adjusted the heap size and used the G1 garbage collector, which provided more predictable pause times. We also profiled the application to identify memory leaks, which we resolved by ensuring that objects were being dereferenced properly when no longer needed.
How do you handle exceptions in Java? And can you provide an example from your experience where proper exception handling was crucial?
In Java, exception handling is crucial to maintaining the robustness of an application. I typically use try catch blocks to handle exceptions and ensure that proper logging is in place to capture the stack trace for debugging. I also make sure to use finally blocks for cleaning up resources like closing database connections. In one project, we were integrating with a third party payment gateway. There was a scenario where network timeouts could occur, leading to potential data inconsistencies. We implemented a retry mechanism within the exception handling logic to manage transient network issues. This approach reduced the failure rate of transactions and ensured that the system could handle temporary issues without user impact.
What are the differences between HashMap and concurrent HashMap? In what scenarios would you use one over the other?
HashMap is not thread safe, which means if multiple threads access a hash map concurrently and at least one of them modifies the map, it must be externally synchronized. On the other hand, concurrent hash map is designed for concurrent access by multiple threads, where it allows modifications by multiple threads without the need for explicit synchronization. In one of my projects, we used concurrent HMAP in a multi threaded environment where the application required high performance read and write operations. We chose concurrent HMAP over HashMap to avoid the overhead of synchronizing the entire map and to ensure thread safety without significant performance penalties.
Have you worked with multithreading in Java? Can you describe a scenario where you had to implement a multi-threaded solution?
Yes, I have experience with multi threading in Java. In a previous project, we needed to process large datasets concurrently to speed up the processing time. We implemented a multi threading solution using the executor service to manage a pool of worker threads. Each thread processed a portion of the data, and the results were aggregated once all threads completed their tasks. A specific challenge was ensuring that the threads did not interfere with each other, particularly when updating shared resources. To handle this, we use synchronization mechanisms like reentrant clock and made use of thread safe data structures like concurrent linked queue. This approach reduced processing time by over 50% compared to a single threaded solution.
Explain the role of Spring Boot in your projects. How has it simplified your development process?
Spring Boot has been a game changer in several of my projects. It simplifies the development of standalone, production grade Spring based applications by providing defaults for configuration and integration. For instance, with Spring Boot, we no longer have to manually configure the underlying Spring context. The framework auto configures it based on the dependencies in the project. In one project, we needed to quickly build and deploy a microservice architecture. Spring Boot's embedded server and easy configuration allowed us to set up microservices with minimal boilerplate code. The auto configuration and starter dependencies drastically reduce the setup time, allowing us to focus on business logic rather than configuration. Moreover, Spring Boot's actuator module was invaluable for monitoring and managing the microservices in production.